Okay, this is your 4.8 coin and interest problems. You are assigned 1 through 5 odd and then 13 and 15. These take a little time, so that's why you don't have as many assigned to you. I want to go through a few of them just to help you. The other ones, hopefully, you can do on your own. Now let's start with number 5. Let's read what it has to say. A bank teller, again, pause this when you need to so that you can do it on your own. Don't just listen to the video. Pause it and try to do it, then play it again, pause it again, and just try to work through it with the help of the video, keeping you on the right track. All right, number 5. A bank teller knows that she received 34 dimes and nickels from a customer. If the change totaled $2.05, how many dimes and nickels did she receive? All right, let's look at what we know already. Well, we know that we have 34 of these together, right? We have 34 dimes and nickels combined, okay? So number of coins, well, we don't really know how many of each we have. We know that they total this. So what we can do is we can say, well, if we just make one of them X, then the other one should be 34 is the total, right? It's 34, take away how many dimes they have, would be what remains, and what would be how many nickels there would be. Does that make sense? The total amount minus how many dimes would equal how many nickels. So you can use just one variable to represent that. Okay, so we know how many of each. Now the question asks what? How many dimes and nickels did she receive? You see, the question is asking about the number of coins. So it's logical that the question is going to have the variable. Okay, the number of coins is going to have the variable. All right, in our equations of coin problems, if you take the number of coins and multiply it by the value of the coin, it will equal the total value of those coins. Okay, so if you have X amount of dimes, or let's say you have 2 dimes, and each dime is worth 10 cents, so write 10 cents. So 2 dimes at 10 cents, 2 times 10 cents, or 0.10, is 20 cents. And that's how much you would have. It's logical, right? If we don't know what it is, it's our variable is X times 0.10. That is how much the total value of our coins would be. So you would say 0.10x. That is the total value. We don't know what the total value is, but we know, once we know this, we will. And this can represent the total value if we just use this as our number. Okay, so this is what we're solving for. Likewise, see, this gets a little tricky. The nickels, 34 minus x, that makes sense. But now, how much are nickels? Nickels are 5 cents, so we put that value in. If we multiply the 5 cents times the number of coins, that will give us the total value of the nickels. Now this one's tricky. Don't be tricked by this one. Don't just put 0.05 times 34. Okay, you need these parentheses. Do you see why? It is 0.05 distributed, right? It's 0.05 times this whole unit, So when you get this in an equation, you're going to have to distribute that 0.05 times each of them. All right, now, what other information do we have to finish our equation? We know we filled in the whole chart, but we need more information to make an equation. Let's reread the question. A bank teller knows that she received 34 dimes. Okay, that's how we made this. And nickels from a customer. If the change totaled, so if both of these totaled $2.05, how many dimes and nickels did she receive? So there we have it. We have an equation right there. Do you see that? Again, it's tempting to put this in here. That's the total value is not 205 here because the dimes aren't everything and the nickels aren't everything. So you have to figure this out with your variables. And then usually the total amount is the combination of the two, but not always. In this one it is. So if we take the dime value and the nickel value, it should equal this. So we use that as our equation, 0.10x plus this value, 0.05, 34 minus x, and that should equal $2.05. Now you can solve for x. This one might be a little tricky. I might suggest to do what you did last lesson last week, and that is to get rid of your decimals. That sometimes helps in solving these. And in order to get rid of a decimal that's 2 place values away, you would multiply by 100, remember? And then you distribute it to each one. But if I do it to that side, I have to do it to this side. Now I put these brackets here because you have to remember you have to do it to each term. This is a term, and this is a term, okay? This is multiplied here, so a term is separated by pluses and minuses. So this whole thing is a term. So what you can do is just multiply the 100 times this, and that will translate through the whole thing, okay? This is one term. So 100 times 0.01 just moves that decimal over 2 times, gives you 10x. 100 times 0.05 moves that decimal over 2 times, gives you 5. You see how this cleans it up, helps you to solve it easier. The 100 will move that decimal over, you'll have 205. Okay, and then don't forget to distribute here first before you do anything with adding. Don't be adding this plus this. They're not alike terms, and you have to multiply first. Get rid of these parentheses. That's multiplication. So multiply here and here, and then you're going to add some like terms and solve. I'm going to let you finish the rest of that solving on your own. Check with your mom or dad if you get stuck, and they can work you through by looking at your solution sheet. All right, that's number 5. Let's do one of these interest problems. The next assignment was 13. Let's do 13. An investor has 500 more invested at 7% than he does at 5%. All right, already I know I have some invested at 7% and some at 5%. Okay, this is our, remember our equation for investments is our principal, that's how much you put in. Our rate, well, the rate you have is at 5 or 7%. The time it's in, usually it's 1 year. Not always, but usually it's 1 year. And then the interest that you gained. Principal times rate times time equals the interest you gain. Or not gain. All right. This turns out to be a negative. You're losing money, right? All right, what is the principal? Let's keep reading. We know that between the two, an investor has 500 more invested at 7% than he does at 5%. If his annual interest rate is 515, okay, so the annual, there's your annual, that gives you a clue of how long it is. Annual means 1 year. Annual interest rate, annual interest rate 515. Okay, there's another clue that we have for our equation. Now, don't be tempted to put this as 515. It's the annual for both, okay? You can't just stick this in here and stick this in here. Then you're telling me you have 515 for 7% and 515 for 5%. That's not right. Well, let's go back and figure out what is right. All right, first of all, these are easy. The rate for this one is 7%, right? You remember how to make a percent into a decimal? It's 100 over 7, right? So when you make a percent into decimal, you move it over 2 decimal places. And that would be how you'd write your rate as a decimal, which is what you want to use in any equation. You want to put it in decimal form. You could also do fraction form, but decimal form is easier. Again, move over decimal 2 places. That's times 100, right? To give you the decimal form, it would be 0.05. So there's your rates for each one. And the time we heard was annual, so that would be 1. You got that filled in. Now, the principal is the harder one. It says an investor has 500 more invested at 7%. So 500 more at 7% than he does at 5%. Pause it and figure it out if you can figure that out. So the comparison happens, he's comparing the 5% and he's saying you have 500 more here. So logically, you should put the X here and the 500 more, okay? The 7% is being compared to the 5%. So that's going to be X plus 500. This is just going to be X. All right, now we can write our equation. We know what these are going to be because all we do is multiply across, and then we will get the interest of both of them with a variable. So X plus 500 times 0.07 times 1. We know 1 times anything is that thing, so we can just really leave that off. But here's the tricky part. See if you can guess what I'm going to say. You can't just put X plus 5 times 0.01 0.07, it has to be this whole thing times this. In order to make that happen, you have to have those parentheses. This whole thing times that. So in your equation, guess what you're going to have to do? Distribute it to each term in that parenthesis. This one's simpler. It's just 0.05x. Now, the interest of this plus the interest of this is the total interest he got. And voila, we know that from the words we read was 515. So you should be able to write that equation. Let's try it. This plus this totaled this. So your equation should look like x plus 500 times 0.07 plus 0.05x should equal 515. Now again, you may want to just multiply by 100 right away. It will help you in the end so that you don't have decimals. So if you multiply this side by 100 to get rid of these decimals, you should also multiply this side by 100. It'll give you a bigger number here, but that's not a big deal. Multiply by 100 adds 2 zeros. And then on this side, multiplying by 100. This is one term here, right? There's no plus or minus here. Plus or minuses are what separates terms. So this 100 you can just multiply by just this. When we distribute it, it will distribute among that. So you just have to do one of those in that. You can't do one of these, okay? You'd have to put it to both of these. This is the one you want to go with, okay? So 100 times that. Don't forget your parentheses because it still is multiplied by this whole unit. 100 moves the decimal over 2 times, which leaves us with 7. And then you're distributing this 2 right to that term and now this term. 100 multiplied by 0.05, decimal over, gives us 5x. Now you distribute again, right? Don't be tempted to combine anything here because you still have a multiplication here. Remember your order of operation. You need to distribute and get rid of this multiplication first. Then you can do some combining of like terms and solve for that x. All right. The question, remember, on 13 is how much does he have invested at each rate? So how much is invested? That's your principal. So once you get x, don't just write x equals. You need to do x and then add 500 to it and label it. At 5% he had this much. At 7% he had this much. Finish the problem at the end with words and with both percentage rates and what the principal was. All right, let's try one more. See if we can fit one more in before my camera shuts off. If it shuts off, you'll have to finish it on your own. 15. Let's read through 15. 15 says, an investor has 7,500 invested at one rate, 6,200 invested at a different rate. If the second investment is at a rate 2% lower than the first, find the rate for each investment if his annual interest is $698. All right. Well, I heard at the end, if his annual interest is $698. I think I said 700. So annual I heard, and I heard annual of both, right? Not just one. He said find the rate for each investment if his annual interest is $698. So these two are going to equal this. Don't be tempted to put this somewhere in here. Doesn't go in there. It's your end problem, okay? Now let's see if we know any of these. Sorry about the phone. We'll just let that ring. An investor has 7,500 invested at one rate. So let's stick it in. We know that one of them is 7,500. And then 6,200 at another rate, okay? We don't know what the rates are. We just know they're invested this much money. We do know something about the rate, though. It says, if the second investment is at a rate 2% lower than the first, okay, 2% lower than the first. Okay, so the 2% lower than the first. It's comparing this one to the first one. So if it's comparing this one to the first one, it makes it easier if you make the first one x. And now the comparison says the rate is 2% lower than the first, okay? So if we take the first and we take away 2%, right? 2%, remember, is 2%, but we're not writing as percent. We write as decimal, which would move it over 2 spots, 2%. Okay, so x, this rate, minus 2%. Now, did you hear anything about annual here? Because if it's annual, we know this time is just 1 year. I heard annual interest is $698, right? So that annual should clue you into this is 1. Okay, sometimes it'll say months, and that will be tricky. That'll come later. All right, so now we know what the interest rate is here using a variable. We just multiply across. 7,500x times 1. We can leave off because it's the same. This one, trickier. What are you going to do with this? You can't just multiply this times x. Don't be tempted to write 6,200x minus this. You can't do this. This is a big no-no. This is a unit. Stays together. Maybe you want to write parentheses around that every time. So that will remind you that if you're multiplying those two, it has to multiply, cross, and distribute. Okay? All right, so we know the interest rate for the first one. We know the interest that we're going to get on the second one, and we know the total interest between two of them. I bet you can write that equation easily. 7,500x plus 6,200 times x minus 0.02. Together, they're going to equal $698. All right. You don't have to multiply by 100 here to get rid of this decimal. You could, but when you multiply this out, that decimal is gonna disappear anyways. So I wouldn't bother with that. And it's not a decimal that's right here. That's when it becomes tricky. So you can probably solve this on your own, I'm thinking. Remember, this is going to be the first step, okay? Don't be adding this and this. Okay, this is, for one, it doesn't have an x and this does, but for another, your multiplication comes first. Distribute first. Okay, then you can combine like terms and solve for your 698. Use a calculator for some of these. This times this, you don't bother doing this longhand. Use a calculator and you can solve it. All right, hopefully this helps on your lesson on interest rates and money.